Hello, my name is Giray Soytürk and I'm here to present our homework for the lesson Computer Vision. This is our first homework and the topic of the homework is finger detection. In this video, I'm going to present you the code we wrote for the solution of the problem, and I'm going to show you the results of the code when we implement the code on the video. So at the end of the video, or in every time actually, I'm going to make some comments about what we did and why we did it. So let's begin to see our code and talk about it. First of all, I would like to say that videos are actually frames. Videos consists of frames. What is frames? Frames are images or pictures. So by this logic, if we can process images or frames, we can process videos. So first of all, we have to read the video from the memory, and thankfully MATLAB has a built-in function for this, and I actually documented this code for every eye to see clearly. But I'm going to explain, of course, what we did and why we did it. So let's begin. As I mentioned before, video reader is the built-in function for reading a video from the memory. It takes one parameter and it's the name of the video, and when we read the video into a variable, we can use the properties of it. We have three properties here, as you can see. Let me leave this to end and start with these two. As we know, height and width, of course, are the height of the video and width of the video. We are using this, we are reading and storing these properties because we are going to use them in our algorithm. I'm going to explain it when the time comes, but I'm going to I would like to talk about this property, number of frames. Number of frames will give us how many frames does the video that we roll, that we read, that we have read. So by knowing how many frames that we got, we know how many frames that we can process. So these three properties are going to be used in somewhere in our algorithm. So initiating to finger matrix. Okay, we are initiating two matrices here, as you can see, and their names are finger and finger 2 respectively. Finger matrix is a zeros matrix which has the height, which has the size, is more correct, I think, which has the size video object dot height property times n frames. Why we did this like this? Let me explain it. We are going to, in our algorithm, in our detection algorithm, we are going to scan the rows for each frames. we will scan every rows for each frame, for all frames. So we have to have video object dot height property size for our this parameter, and n frames parameter here size, I mean, is a necessity because we are going to process n frames amount of frames. So we are going to scan video object dot height times n frames row. So I think we are done with that, and let's talk about finger 2 matrix. Finger 2 matrix is a bit different. So the thing is, the finger 2 matrix is a zeros matrix too, but it has the size 1 times n frames. Why 1 times n frames? Because we are going to write one value from the finger matrix to finger 2 matrix for each frame. I'm going to explain what or which value that we are going to write from finger matrix to into finger 2 matrix when the time comes, when the turn for it comes in the algorithm. But generally it's enough to know its size and what we are going to do with it. So now we have an loop. We have a loop here, and this loop for k equal to 1 till n frames, this loop is, as you can see, ends with at the end of our code block, or as we can say, what this for loop does is it makes possible for us to process every frame, because we are going to process n frames amount of frames. So by looping that much, we can process every frame. Now it's another built-in function of MATLAB to read not video for this time, and it's reading the frame from the video, and it takes 2 parameters. The first one is video object. Video object is the variable which we have read here from the video reader function. It means, let me explain this way. Read function takes 2 parameters. The first one is the video, and the second one is the matrix, not the matrix, the index of the frame. So in English, in proper English, we can read this as like this. I want to read the kth frame from the video object. So after we read and store the frame into im variable, we can make some adjustments. We are resizing the image and rotating it. Why we resize the image? Because some videos and some photos we took and we tried to process them, but with high resolution pictures we got some problems. MATLAB's imshow function complains about it, and to get rid of this, we resize every frame into their half size, and the video that we are going to process now, the computer understands it in a horizontal way, but although we took it vertically, we had to rotate the video, I mean each frame, of course, because our detection algorithm will be scanning all the rows, so we want the hand in this way, not in this way. So yeah, that's it. Now we are getting some interesting stuff here. We are converting our image into grayscale image, because we are going to use thresholding algorithm to our image. Our algorithm's essentials depends on it. So we are converting our image into grayscale, and we are using histogram equalization here, because when we didn't use it, we got some problems, and histogram equalization is a helpful way when using thresholding algorithms. So we have another for loop, or for loops, of course, here, nested loops. Now, what this is doing, this block of loops makes it possible for us to read all the image for all rows and for all columns. So we are reading every pixel value respectively, from the left corner till the right hand corner. So, and we are checking the pixel value, and we are comparing it with our thresholding value here. For this video, for this video's frames, we are going to use 210 as thresholding value. If the pixel value that we are checking at this present at the moment is less than 210, then for us it will be 0. It will be black pixel. It will be 0. And of course we have an else statement here, and if it is bigger than the pixel value that we are checking is bigger than 210, it will be 255 pure white. So why we are doing this? We are doing this because we want to make the contrast high, because our algorithm will detect fingers, and we would like to know here is a finger, but not we don't want black dots here, here, here on the background. We just want fingers. So fingers will be white, and the rest of the image or frame, I mean the background of the frame, will be black. We want our hand to be shown white and the background black. So if we have white dots outside the hand of ours, this will break our algorithm. So we are trying to reduce the noise in the frame. So after this, we have a function here named imDelete. imDelete is a built-in function in MATLAB. We didn't code it. We found this after our research. imDelete function have effect on regions that we gave this parameter disk. We gave here disk because our fingers, has round shapes. So in the picture, we don't want any other roundly shaped areas. So we are using imDelete function with disk parameter. So what we are doing actually here is we are trying to make everywhere black outside of our hand. Our hand and our fingers will be white, and the rest of the image frame at the background will be black. Sorry, I'm a bit ill. Now, this is our finger detection algorithm logic here. We are scanning the image. We are scanning the frame from left top corner till the right hand corner. So what we are doing here, we are trying to find pixel value differences. Like what? In this if statement, you can see that we are checking pixel values, the following a pixel value and its following pixels value. So if a pixel's value is bigger than its following pixel's value, then there must be a transition, because there are only 255 pixel values and 0 pixel values in our picture now, because we thresholded and we used thresholding algorithm here. And if there is a change, it must be because of our finger, because we used imDelete function and histogram equalization and thresholding for get rid of the noise of the frame. So if there is a transition from black to white, it must be here. But we are checking if there is a transition from white to black. So entering a finger will not be counted as a truth for this if statement, but leaving a finger, because fingers will be white and the background is black. So what happens? From white pixel to black pixel. White is 255 and black is 0. So what happens here? The if statement comes true and finger value will be incremented. So that means there is a finger here. So I'm going to show the results of the algorithm, of course, but I'm just trying to make a point here, make it visual with my hands. Let's see. Yeah, we are almost done to check our code. We are going to see the results, of course, in a minute. Now, as I mentioned before, there were two matrices, finger and finger 2. I mentioned that I will explain what finger 2 matrix will store. So, in every cave frame, we are going to find the maximum of the maximum value of the finger matrix and then store it in the finger 2 matrix. Why we do this? Because let's imagine the background is totally black and our hand is white. So I'm doing 3, of course. Yeah, 3. So our algorithm scans the picture and whoa, what happens here? From this point to this point, 255 to 0, a finger. It found 3 fingers. But yeah, it found 2 fingers. But it could have the frame could have included my hand too. If my hand is in the frame 2, what will happen? Yeah, a total my hand will be counted as a finger. Yeah, if we didn't take the maximum, because we took the maximum, you get it. So now we are almost done here. Position value is for writing the finger count on the frame. Which position you would like to position your text on the picture. We are going to store this in position variable, and insert text is of course built-in MATLAB function, and it makes it easier to write texts on pictures. And I have a font size here at the value 26 because it can be more readable, and then of course we are showing the image. Let's see what happens when we run our code. I am clicking it, and yeah, it is working here. As you can see, it shows 2 here. It finds 2 fingers. Why it finds 2 fingers? Because we are taking the maximum value. As you can see, there is a distortion here, but it is not a problem for us because it will count maximum as a 1. But yeah, it is coming out, and it is 2 fingers now. It really is 2 fingers now. I'm going to explain why it was 2 when the finger count was 1. I'm going to explain that, but now we can watch the algorithm working here. As you can see, we can see the fingers in a good way, but they have to be they have to stand separately. This cannot be understandable for our algorithm, because as you can see, if when we are scanning this, it will be just one transition here, so it can see this like one finger. Yeah, our algorithm works, and 3 fingers here and 3 here, so good. Yeah, and the 4th finger and the 4th finger. Yes, now we are getting our result. Yeah, so I'm stopping this here. Okay, and we can see our variables here in our workspace. Yeah, we saw the implementation of our algorithm. So it found fingers fine, correctly, but it had one miscalculation. What was that? It showed 2 fingers. It counted 2 fingers while there was 1 finger. Why was that? Because I wrote this on the report as well, and I'm going to explain this here too. Some conditions must be satisfied for our algorithm to work. One of them is enlightenment, of course. The other one is the background shade, because we are using darker shades to get good result, and because if we don't use darker shades for our algorithm works like this, but other algorithms maybe works fine with pale or lighter shades. Doesn't matter. We are trying to keep the background as possible as clean, as we can say, clean, not have noisy points or noisy regions that will make our algorithm work faulty. I don't know. So yeah, I was telling about why it showed 2 fingers while there was just finger. So standing of the fingers is another condition to have to be satisfied for our algorithm, because if there was 1 finger like this, it will calculate it correctly, because every scanning would give 1 maximum point. But when the finger stands like this finger is a bit up. When scanning this row, it sees 2 transitions from white to black, so it counts 2 fingers. So as I said before, the standing of the fingers is an important condition to be satisfied. So we talked about our code and our algorithm here, and I explained what we did and why we did use some of these functions, or thresholding, or RGB to gray, or histogram equalization, some like that, and we saw the results of our code. and I explained why it has pros and why it has cons, and what has to be satisfied for our algorithm to work correctly. So to sum up, of course there can be more correct and more beautiful algorithms, of course, but we try to think different and use some, not one function or not one algorithm, and we try to combine some of those, some functions, some techniques, histogram equalization, thresholding, like that. So thank you for listening me and watching me, and I hope it was clean for you to understand what we did here. So thank you very much and have a good day. I'm Giray Soytürk and my student number is 1405238. Thank you.